Today on the Captain Chaos Laboratory, where we're going to work on the next Lemax, is a Zombie March. This was sent to me. It was purchased from, I believe, Macari. I could be wrong. It was sent to me directly from the seller because it doesn't work. And it actually arrived in, for the most part, one piece. The listing stated that the characters came unglued. So this was already like this. And that they previously worked on it trying to get it work because it does not function. And it is plugged in. First thing I noticed, I haven't torn into it yet, is this switch. It's not right. I think it's coming apart internally. So we're going to open that up. This has been opened and attempted to be repaired, like I mentioned, because this disc, if you can see this lip, fits inside here. It has to be put in from the bottom. Whoever did work on it at least got the bottom off relatively in one piece, and you can see they put a really thick bead of hot glue right in here to put it back together. I try to use a thinner bead so it's not lifted, but it's fine. It's not a complaint, it's just an observation. Looking at the piece, it's a pretty interesting piece. It's actually a rather large piece, as you can see. These squares are 1 inch. So this thing is almost 11 inches this way, and figure 13 inches that way. So it's a really large piece. Takes up a pretty big surface area. So, looking at it, this is how it came in the box. I noticed this zombie arm is missing. It's broke off. I wouldn't complain too much. Was not in the actual OEM box that this came in, so I'm assuming this broke off at some time in the past. Because not all zombies have all their limbs, so I wouldn't be concerned. The box that this did come in, though, was absolutely destroyed. The shipping box. But the person actually packed it really well, because the actual Lemax box for this is undamaged. So I'm surprised, because it's really crushed and full of holes. So we're going to open this up, see what we can find to find out why it doesn't work. And we have to open the bottom anyway, because the whole problem could just be the switch. But we have to open the bottom anyway just to put this back in. So let's take the power back out of it and see if the hot glue will release without using any excessive heat. Which some of it is, as you can see. Now, I'm going to just, since it's a flat top and all the characters are clear of the workbench, I'm just going to set it on its lid, make life easier. Work my way around. The glue's not as sticky as it used to be, since it was peeled off once. This is generally the longest part of doing this, is trying to get in without destroying the mat too much. Yeah, it sounds like it's being broken. I'm just breaking all the glue, not breaking the unit. So I've been using a spudger. I'm going to use a flat scraper blade on an X-Acto because some of this mat has re-adhered really strong. in some spots. Some more of this hot glue out. I'm wondering if they just peeled the mat like a book, because this side doesn't seem to have ever been re-glued. Let's see if I can get a gander inside to see what's... So the circuit board's right here. Your power's right there. So they have the cabling coming to right here. So basically just above the X we have the circuit board. Looks like the drive motor is right about here. So I'm wondering if this is as far as they got most of it open. And they just peeled it. But I don't want to do that because I don't want to catch any of these wires because they're not secured. But the circuit board looks okay. I don't see anything obviously burnt on it. But we're going to continue disassembly. I am going to turn on the heater, and I'm going to try and heat this lip up that's really stuck down, so we try not to tear the mat too much. Now this is going to be a long process, so I am going to just pause it momentarily while I finish getting the rest of this mat broke free so we can see what's inside. So, one moment please. Okay, it has been about 12 minutes, so I want to see how long it takes to take some of these apart to get this to flip over. Heat all the way around to break up the what was left of the glue on the mat, and then you have to take this ring and walk it on these characters here and flip it over. These characters here don't protrude past the disc. These characters here do. Also, while I was in here, when I flipped it, this hand fell out. And this hand does not match this guy. It's way smaller. And none of these characters are missing hands, so I have no idea what this hand goes to. The drive belt also fell out. It's broken. And then I did unscrew this disc just to see if there was any hidden screws at the bottom. As soon as I unscrewed the disc, everything fell straight down because it relieved the pressure on the bound motor and it dropped it. So I thought maybe that something was underneath that would hold in the center to prevent me from trying to lift. So the disc fell as soon as I took the last screw out, and one of the gears fell out because it was bound up. I removed most of the hot glue that was around the edges, like this. Not all of it, just the loose stuff that was going to probably get in the way. So, there's the circuit board I was telling you about. Hopefully you can see it. And there's the drive mechanism, that silver motor sticking out. And then here's the switch. There is plenty of slack, but you still have to keep this within a couple of inches because you have these two red, this red and white wire here. You have these multicolored wires here. Plus you have your switch wire, which is this black cable here. So I think I'm going to have to take the rest of this mat off so I can get this hub assembly out. There are some hidden screws right here in the paint. Let's see, we'll try those first. So there's 3 of them. Okay, look at that. So that's how they got this out. They probably didn't finish taking the bottom off, like I was assuming. That's why the mat was stuck. We have a micro switch. We have some greasy electrical tape. Get that out of here. Can I get this all the way off? Is there enough slack in the wiring? No. Okay. Alright, there are 3 more screws right here. Hopefully these 3 screws will remove the rotating character. So I can get to the circuitry and the drive mechanism and where the switch comes in. Apparently that just lifts off. And yes, it does lift the inner ring where everything's hidden. So here's the planetary gear that allows that to spin without rotating, and rotate this, because this rotates the opposite direction of these characters according to the video. And then those 3 screws do allow me to lift off this plate. So I'm just going to push the screws in so they don't get lost. Alright, and there's this belt. It's intact. So this smaller drive belt must be the drive belt for this up and down piece, or it doesn't belong to it, like this hand, which I've got no idea what the heck the hand's for. So just gonna turn it so I can get a better view of what's going on here. We got the typical cheesy Lemax solder wires where they soldered it and they're just bare connections. That's pretty common. They usually put a dab of glue on them and then glue them down so they don't arc, but when that glue chips off, that's it. Let's see, we have, this is the drive motor down here next to this big relay for the big ring. That's the motor plug for this guy, the inner ring. This is the speaker. They're also labeled, but they both say motor, so I'm trying to trace the wires. You got your blob chip next to the relay on a vertical plate. We have a bank of resistors, some transistors, capacitors. I see nothing obviously burnt. Screw the circuit board. Take a look at the bottom. On the bottom we have all the solder connections and 1 capacitor, 2 capacitors. I'm going to take a picture of the circuitry, so in case any of these wires pop off. I know where they go. Okay. So I got me some pictures. I don't know if you can see it, but that's the blob chip right there on that vertical board. So I'm wondering if most of the problem of why this doesn't work at all is if it's in the switch. So I'm going to go ahead and pop the switch cover. You can use your fingernail or a pair of pliers, a screwdriver. Pop it open. There's a small screw in the center. It'll let you take the wheel off. Then under the wheel we have 5 wires that are soldered to connection points. They all appear to be intact. Grab my meter while I'm here, so we have that ready for testing power. There it is. So yeah, the white, green, blue, yellow, and gray wire are all soldered. The white and gray appear to be the main power. The yellow, green, and blue would be auxiliary and volume. The possibility of the switch feeling funny is the center screw was loose. If the center screw comes loose, it doesn't always turn on and off. Take it open or pop it open and then tighten the screw. It still feels bad. I think it's a bad switch. On this one, the white and the gray wire are soldered to where the screws go. It's usually where the main power would be. They're also fatter, which indicates main power. I'm going to take the switch completely out and check the back of the switch. On the back of these switches, let's feed it around. Now try and zoom in a little bit. Focus. Maybe I zoomed in too far. Doesn't want to focus. It's a little better. When you rotate this with the wheel, there's a ball detent and a spring, which is your click, and it feels weak. And I'm wondering if the ball detent is the problem and the switch is okay. It's just got a weak spring. So I'm going to screw the wheel back on so I can use that versus trying to squeeze that small piece of metal. See how it lifts right here? Here's your click. You notice when I click it back, it's not clicking. And then here's your incoming and outgoing. So y'all can see how this works. Focus. Come on. There you go. So this is your connection from here to here. See the gap? And if I turn the wheel, and it's now connected. The spring is doing is pulling this little piece of metal down to make a connection from the outer pins, which is your power. That's what breaks the connection between on and off. If you have one of those units that when you turn it off it continues the cycle, it's breaking the connection here, but it's still allowing the connection in one of these 3 pins, probably the center one. So it can do its power down cycle to its reset point. So if you never paid attention on how these work, that's how it works. If this spring breaks, usually the switch is garbage. Come on. Stay in focus. There you go. If this spring breaks, it's usually garbage. You can attempt to rewind the spring or find another similar spring from a hobby store maybe and fix the switch, because these switches are hard to find unless you can find some donor Lemax pieces. And we'll zoom back out. Wrong way. There we go. So the switch does appear to be functioning. It just doesn't feel as crisp as it should. So I'm going to turn it off so that gap is open. I'm going to plug it in. Try it again. According to the switch, we should have good power going through this. And that's why I wanted to get this out, so we can check the power. I got 4.6 volts coming in from the power supply. So all the pins, except for this one, have the same, yep, there we go, they all have the same voltage. Okay, just a bad connection. So I'm going to trace the wires in. The wires coming from that unit, like I said, the main power wire is gray to white, and then we have green, blue, and yellow. So on the back of the circuit board, we have the main power wire, which is gray and white, which goes there, just to the side of this capacitor, and the gray wire goes all the way over here. I'm smelling it to see if I smell anything that's burnt. Because right now the circuit board is getting power through those auxiliary wires. And the Lemax power supply is slowly increasing its voltage. Now we're going to flip on the switch. It's a bad switch. Yep. So the whole reason this isn't working is this switch. You saw the voltage was changing. When I put my meter in there and I put tension on it so it would stay in place, a little bitty click happened. That click was probably an arc, and then everything started working. And then if I turn the switch back on, see, I have to keep it. Yeah, so it's got a bad switch. That's the first problem, of course. The second problem is I got a broken drive belt. And we saw this one spinning. So, first I'm going to do is move the meter out of the way, since we know we're getting good power and everything works. I'm going to move my razor knife so it stops falling, because the last thing I need is to cut myself. I am going to fix all these bare connections, but now we need to reassemble this and figure out where all the parts go. Because, yeah, this doesn't have a drive belt. Look at that. It's just, get some of that. No belt. So, this unit's kind of bare to open. Like I said, with the alignment of this and getting this mat part off. At least you only have to peel the edges of the mat. Now, it kind of looks like a taco shell with the wrinkles. It's okay. A lot of times glue will fix it, but you can also use the same heat that you applied to separate the mat. Will flatten the mat out when you put it back on. Because I have had questions about that. Now I just need to find a small drive belt in my pile of belts. You can find baggies of different size belts on eBay and Amazon. Just look up electronics drive belts or hobby drive belts, VCRs, DVD players, Blu-ray. Any electronic that has a belt in it, they make generic kits that have different size belts. So we got a belt on it now. Let's see if it actually turns. Get this thing done.
Anybody seen Mary? Buried alive? What a lovely night for a walk.
So it is not turning.
Where you going?
Now it is.
I wish I had my bicycle. Where's my bicycle? Oh,
Okay, so it does turn, it just has a delay. I'm just going to unplug it because I don't want to keep playing with this bad switch. I don't want it to arc and backfeed the board. Now I need to find the missing parts. When I took this apart, unfortunately, the gear that, here it is, stuck to the bottom. The gear that transfers over fell off. So, there you go. This gear goes on this pin right here and sets in here, which takes this little itty bitty 8-tooth and transfers the power into this base gear with a worm gear that makes it go up and down. Before I put it all together, the standard thing I like to do is I want to check all the gears, because gears are notorious for breaking. Especially these small guys, the 8 and 10 teeth gears love to come apart. And this little 8-tooth appears to be good. I don't see any cracks. There's no big wear marks on it. I'm sure it's a brittle gear just because of its age. It looks good. So I'm going to lift this back to the top where it was. I'm going to try and set this together. Alright, I'm going to take it off because this is actually a little harder than it looks. Since there's no stud in the bottom or alignment pin, this little gear that I put on likes to walk. It doesn't want to fit in square. Plus I have to rotate the gear for it to drop into the teeth. There we go. Thinks we got it. Let's run a screw. Make sure it stays together. That looks good. I'm going to put the 3 screws back in, and then I'm going to check it against the shaft that's threaded or got gear teeth on it. Make sure it goes up and down like it's supposed to. Like that. Alright, here goes nothing.
anybody seen Mary? Buried alive? What a lovely night for a walk. Where you going? I want land. I wish I had my bicycle.
Alright, how does it know it's at the top? It's continuing to go up because it doesn't know it's at the top of the shaft, so there's a switch somewhere missing that I'm not seeing. Here's the bottom. that tells it it's all the way down. There's got to be a switch that tells it's all the way up. But it is working. There's nothing on the inside with wires. What I'm doing is reversing the polarity on the motor to make it go back down. I'm doing it manually. I want it to go all the way to the bottom of that micro switch. Like that. There's nothing. You see no way for this unit to know that it's not at the top. Okay. There we go. Okay. I think I understand how it works. I'm going to wait for it to drop back down and see if it works like I think it does, and I'll explain it to you. Let's do it one more time. Okay, I have an idea how this works. A lot of units, if you've ever opened them up, will have two little micro switches. One that tells it to go and one that tells it to stop, so it knows where it is in relationship to the shaft of teeth or the gear spin. This is counting. It's got a logic chip that is probably built into the blob chip, because this chip right here is not a chip for logic. This chip right here is the amplifier for the speaker. So it's saying it's going to take X amount of turns for me to hit the top and not go over. Or it'll say it's going to take 3 seconds. If there's a chip that's counting either the revolutions or the teeth. I want to say there's a little eye in here inside the black housing in the center that's looking at the teeth as it hits the top. Because you can hear this clicking. This is the relay that controls the lift. It's engaging and disengaging the motor's polarity and the motor itself. That's why it stops, because it's supposed to go up and down and then rotate. It's not rotating because, of course, the rotation gear is sitting right there. It's not broke. It's just not hooked up. So this is a house that should probably have to be reset, I'm assuming. I'm assuming when you turn it off, which I'll try one more time. I really don't want to screw with that switch too much. I want to see if it resets itself to 0 so it knows where to count from So, 2. So, the switch is off. With the switch off, it increased the volume. Not sure why, but I bet you when this goes all the way down and touches that micro switch, the unit's going to turn back off because the switch contact is now open. So if I'm correct, this is a house that you want to turn off manually every time, just so you don't mess up the logic that's being sent to it from the block chip. If you do it every once in a while, it's not going to kill it, but if you continually power it off via incoming power, that cycling of power can screw it up. Yep, so there you go. So this is a house, or a piece, because it's not technically a house, that needs to be powered on and off via the switch, not this. That's why I'm always getting constant power on the additional wires. Those constant power on the additional wires is to allow it to do its reset. Banshee's booby traps, the mausoleum, RIP mausoleum, I believe. There's a handful of houses out there that require you to turn it off so it can reset, because it can damage the logic chip if you don't. It is rare that you'll damage a logic chip, but it does happen, and it's better to be safe than sorry, because you can't replace them. They're irreplaceable parts. Lemax does not carry spare parts. I know I've asked them a dozen times. And then on this one especially, now if you have a power outage, there's no control, but on this one especially, since it's using either a sensor eye or a count to count these teeth, it may not remember which direction it was going when the power was cut to it. So if it's halfway up and it was going down, then it says, oh, I got to go back up, and it's going to count 30 teeth. 30 teeth would be up here from the halfway point, which is going to push this disc onto this inner lip, causing the gears to break. Hopefully you just break the worm gear. It's replaceable. If you break this ribbed shaft, you're going to have a bad day. Basically, this shaft is one of these. You got the teeth sitting right here, but it's shaped into the X or cross, so it can keep this aligned on the bottom. While this spins freely, the bottom stays in place. You can probably 3D print something and then adhere a shaft or a track like this into its place, because this track is, well, it's a little wider. But it looks to be the same teeth. It is. So this is the same tooth pattern, spacing. The track itself is a hair wider, so you'd have to trim it so it fits through. It can be repaired. It won't be an easy process. So if you can remember, if you have the Zombie Parade, I believe that's what it was called, turn it off, because we don't want this to break. So now comes the reassembly. We know what the problem is. So got to reassemble this hub, and I got to find a switch. That's going to be the next hard part. I've had spares. The problem is I've given most of them away to people who have bad switches. So I got to go check my stock of spare broken stuff and see if I have a off-on switch with 5 connections on the back. Most of them always have 5, but there are the exceptions. And see if we can desolder and resolder the connections and get this thing repaired so it can go to its new owner. Since the new owner doesn't even have it yet, it was shipped directly to here to see if it can be refixed. We're also going to have to chisel out all this extra glue so we can glue it back together, and then glue on the characters so it can go back in its box. So basically, peel the edges carefully. You don't have to take the whole mat off, which is a definite plus. Crack the glue, little blade screwdriver, spudger, heat gun, get the glue to break free. I did it upside down. Now if this is missing or recessed, you can do it upside down and lay it right on this top. But if it is not and it's sticking up, you're going to have to do it on its side, which can be a lot harder. Or use the foam base and put the characters that are sticking up into the hole for this and see if that helps hold it elevated. Break the glue, slowly peel it free, flip it back over on its bottom, and rotate this outer casting to where you can get it over these characters. And then look at the characters, and you'll see what characters' bodies protrude past this ring, such as this lady with her hand. You know, her hand's protruding past the ring. Put her on the side. If you lift it this way, she'd be on this side. So the ring lifts over the people who aren't protruding past this. Lift it like a door and then flop it over. Careful not to pull it. These wires here are a little bit heavier gauge than these two wires here. These wires here are your light wires. This red and white wire comes right off of your power. So these two thin wires are your incoming power. So there's a chance that you can rip them off the circuit board or rip them off here. If you do rip them off, hopefully rip them off here, way easier to fix. So these right here are probably twice as thick, much thicker gauge. And of course this cable has strain relief, so you're not going to damage it going through the base, but you can rip the 5 wires off at the bottom of that circuit board. And then you're going to have a bad day again. So careful when you do it. Just peel it slowly, flop it over as you saw, remove those 3 inner screws after you pull the hub out, and just slowly disassemble and stack it. Maybe you'll have a surprise inside of somebody's hand, again, not a clue, and a broken belt. Go on Amazon, eBay, etc. Look up belts, baggies of belts. You can go to Skull Crane Animatronics and get a repair kit. They come like this. The belt that's in there is about the same size as this belt. That is not the belt I used. I used a little bit thicker belt. So hopefully it'll last longer, because it's a thicker belt. Means it should take more to wear down. So if you have to open it though, in this case I had to open it to put it back together from the previous person, and unbeknownst to me, we had a broken drive belt, so it had to come apart anyway. Normally I tell most people, when you have a off-on sound volume switch like this, check your switch. It's most commonly the failure point, because it is the point that you're rotating on and off every time you turn your unit on and off, especially if it has to be reset. Check the solder connections. They use lead-free solder. Lead-free solder is known for cracking and coming apart, and that's a big issue. This switch feels wrong because it doesn't have the solid connection in the on position, and that's where my problem is. Inside this switch that you can't see is a swiper arm as well, and I think that's where the failure is when I'm wiggling this, I'm actually making that swiper arm connect, because it's actually a small potentiometer. That's why you get the volume control out of it, so it goes louder and quieter. So some basic information. It's a lot of information, but it's very helpful as it pertains to many different parts, or excuse me, other houses within the Lemax line. So, but I gotta go find my box of spare broken Lemax stuff and see if I can scavenge a switch. Solder the new switch in, test it, make sure it functions like it's supposed to, and then you don't have to wiggle it. And we got a good positive on-off click, at which point reassemble, re-glue, repackage, and ship it back to its new owner. So I shall return as soon as I find a spare part. Okay, I found a switch. I have a donor piece. This is the Dark Haven Lodge. Some might recognize it. It's in a bad state of disrepair. It was part of an outside display, but a nice hard click. The switch is still good. So I'm debating if I should just take it out through the bottom or just desolder the switch at the moment. But yeah, this is what you have to do sometimes, because these are impossible to find. You have to get a donor piece that's broken. So we're going to take apart this to fix that. So I wanted to show you what I say go through boxes of parts. I actually have complete houses that I tear apart, as well as box of parts, and all my loose switches are gone because I've sent them to people. So I have to now take apart complete houses that are damaged to get the parts. So that's going to be the next step in the process of doing this. I have 2 choices: desolder, which might be the easiest, truthfully, or take the bottom of the house apart. So I'm going to just desolder, make life easy, and then because the only part that's bad is not this long wire, is just this. I don't know if you can tell, this wire is a lot longer than this one, so it can retain its length, so it can wrap around to the front. I'm just going to desolder. So I'm going to go ahead and take this apart, and take this apart, and then put this part on this part. I'm going to try it again. I might even try and reassemble it so we can get the motion going to make sure that the drive belt, both the original and the new one, are strong enough to make everything rotate under its own weight, because that's a lot of mass, this ring. And then this not only has to go up and down, but it rotates as well. It rotates this and that, which is also a lot of rotational mass. So, shall return here in a little bit, spend some time putting this all together, and hopefully it'll be done. Okay, it's all reassembled. The new pulley belt was put on as you saw previous. I glued the figures back on, put the cover back on, and this is the new switch, but because this switch was outdoors, I thought it would work because it's got a good click. It's really horrible on the sound, so I'm not going to use this switch. I'm going to try and hunt down another one. That's why there's no casing on it. Now the original switch, I think, was exposed to moisture. You can see that white corrosion, and I think that's why this one has a bad click and then intermittently works. I think inside the actual rheostat itself, it's corroded. The outdoor one, surprisingly, there's no corrosion on it. So I was actually impressed that the one that was in an outdoor display was clean. So anyway, it's raising. Let's turn off some excess light. It's kind of hard to see from the aerial that it's going up. So I'll hold it. It's about a 30-second process to go through its cycle. And then, as you can see, it's going down. Turn the volume down so it's easier to talk. If you have this piece and it breaks, do not, and I can't emphasize this enough, do not, sorry for the interruption, take off the bottom. Peeling off the bottom is a bad idea. Everything is accessible from inside here. When you peel off the bottom, I had to align it a dozen times to get this outer wheel not to bind on the outer base. So it's a live and learn experience. I've never taken it apart, but I can tell you what to and not to do to make your life easier. So to disassemble, remove the 3 screws that take this hub out. Pull the hub off. You can then unclip this guy. It has 3 clips. He only has 1 because they were broke off from the previous disassembly. Pop it off carefully. Pull it straight up off of the 3 guide bars. Pull the center section out, which is the 3 guide bars in the gear. You can also lift these characters off and set them aside. There's 3 more screws, which allow you to the mechanism in the bottom and the circuit board. The only time you should ever have to access the mechanism in the bottom is to replace the drive belt for the outer ring and this rotation. The gear that makes this spin one direction is making this spin the other direction. So then if you just need to access this, because they're not going up and down, take out the 3 screws, pull off the center hub. Careful you don't break off an arm or something, because his arm sticks over the center base. Set it down, pop this off with the 3 characters, take out the 3 screws, which have the up and down motor mechanism. Then replace the belt. Just lift it off the 3 lift off the 3 studs, or take that inner gear and set it aside again. So then you can change the belt. You can unscrew the gear pack and replace the gears if they're broke. same thing. But here it is. Let's kill the lights completely so you get a better idea what it looks like. In almost pitch darkness. It's actually brighter in here than what the camera's showing. So if we tip it up at an angle, see how it casts the shadows along the inner wall and the characters glowing in their UV or black light glow, picking up hints of the green from the front. Yeah, it's actually pretty well lit. And I do like the ancient architecture on the center section. It actually does look really good. It's harder to see in the camera probably. There's a lot of things that the camera doesn't do justice to, and lighting is one, paint is the other, depending on, again, your lighting. So let's turn this thing off. Helps if I turn the wheel the right way, so that way it resets. So it's all set. Let's get some light on in here. So for now, it's done until I can source another switch. Then all I gotta do is just solder the wires on the back. Just so you know, the center pin is green. So if you're holding it facing, the pin's facing to your right, it goes incoming power, which is on this one gray, blue, green, yellow, white, outgoing power. Sometimes I've seen them white and pink for the powers, but usually the three wires in the middle are always blue, green, and yellow. And generally they're all in the same order. That other house was the same order. It's just the two power wires were different shades. So all we gotta do is desolder and resolder. I'll bring this one back up. You can see the solder pads, hopefully. There's 5. Because they use lead-free solder, use some leaded solder. This is just what it looks like. I just use thin stuff. It's 0.8 millimeter in case you're wondering. And you add a little solder to the tops of them, then you heat that new solder and pull the wires off. You can then use a solder sucker to clean the pads of your new switch, as an example, or solder wick. I would not recommend using solder that is lead-free because your adhesion won't be as good. You have to get it hotter in most cases, and it corrodes and cracks faster than lead. So technically, if this switch wasn't staticky, it'd be perfect. But it's unfortunately staticky, so I'm going to go find another switch. I have another building that has one, and then if not, I got a parts building that I have not removed from the box, and I believe it has one of these as well. So, we'll see. But, this is the Zombie March, put back together, basically fully functional. Just got to source a switch. If you need to take it apart, do not remove the mat. Do not remove that glue on the bottom. Everything comes out of the top, so you can keep it centered for this outer ring. And I did glue the end bottom on, and I glued the mat back on. It's got a little bit of a wrinkle here and there, but it is as flat as I can get it with hot glue and a heat gun. So, all in all, this thing took about 90 minutes or so. Most of it was spent disassembling the bottom and then reassembling it when I realized I didn't have to take the bottom off. So, if you have it, it's really fast, it's really easy, because this one is held together with screws, which is a bonus. So, thanks for watching. Till the next one, have a good one.